Hello class 10th. In the last lecture we have completed our chapter 3 machine and I have solved some questions according to some doubts and I'm waiting for the doubts and your query. Today we will start chapter 4 calorimeter. In this chapter we'll discuss about the heat energy, calorimeter, the specific heat capacity and its equations with units. So first of all, talking about what is a calorimeter. A calorimeter is just nothing a copper tube like this. This is a copper glass, you can say, or copper tube. This copper tube is polished from inside and outside. Why? The heated element or heated substance will be placed inside to prevent the heat energy, to prevent the heat loss from this tube, from this glass. That is why this tube, this glass is polished from inside and outside both. This will prevent the heat loss in the form of radiation. After this tube, there is one stirrer. You can say like a spoon, this one. This spoon will be placed inside that calorimeter to mix the material only. Then after, what will be happen? This calorimeter, this tube will be placed inside a wooden block. How? See this? This will look like that. On placing that tube or a calorimeter inside that block, it will start conducting heat energy to the atmosphere. To prevent, the tube will be placed inside and the tube will be surrounded by insulating materials like wool. Why? Again, to prevent the heat loss in the form of conduction. So we have prevented the heat loss from conduction, second radiation. Now to prevent the radiation, the lid of this box, the bottom portion of this lid is polished, and after covering it, means after closing it, it will prevent the heat loss from convection also. So all the type of heat loss is prevented right now. So why there is a hole? The heat will come out from that hole. That hole is placed to put thermometer and little space for stirrer to move inside, to mix the mixture. So thermometer and the stirrer will be there. So in this way, this is all about the diagram of calorimeter. It's nothing just a copper glass, or you can say copper tube, and it's placed in the box just to prevent heat loss. And using this, we can calculate the heat energy of the substance, of the specific heat capacity, we can calculate these all. So what are these? Let's see in the next term. So starting the chapter 4 calorimetry, it's a branch of physics. Calorimetry is a branch of physics which deals with the measurement of heat energy. For example, if I'm giving you a cup of tea, so can you measure what is the amount of heat energy in the 1 cup of tea? What instrument you will use? If you're saying thermometer, so you are incorrect. A thermometer can measure only the degree of hotness or coldness, how hot or cold than our body. So this is not the device to measure the heat energy. This is only to measure the degree of hotness or coldness. So how to measure this heat energy? That deals with the calorimeter. So first of all, what is heat energy? Means we have to define first. So heat energy is the sum of kinetic energy and potential energy of molecule. Means the heat energy is defined as the sum of kinetic and potential energy of the molecule, in which the temperature only measures the average kinetic energy of the molecule. So average kinetic energy of molecule is temperature, and the sum of kinetic and potential energy of molecule of any substance is a heat energy. Before starting about the units and further, I want to share you that the change in 1 Kelvin is exactly equal to the change in 1 degree Celsius. You will say no, that 1 degree Celsius is equal to 273 Kelvin. I'm not saying that this relation. I'm talking about the change in, means difference. For example, say this. Initial temperature of, suppose I'm taking 27 degrees Celsius. 27 degrees Celsius is equal to how much Kelvin? exactly 300 Kelvin. There it is. And if I'm talking about the 28 degrees Celsius, so that is equal to 301 Kelvin. So in this part, what is the difference? Means change in degrees Celsius. For the change, we will use symbol delta. A small triangle is known as delta, that says the change in the temperature. So delta 1 degree Celsius. Change in degree Celsius is delta degree Celsius is 1. And there change in temperature 1 Kelvin only. So delta K 1, delta C 1. So the change is same, but the value will be different in the different scale. In degree Celsius it is 27 and 28. It's a different scale. In the Kelvin scale 300 and 301. It's a different scale, but the change in degree Celsius and change in Kelvin is same. So what I wanted to say, that the change in degrees Celsius is exactly equal to the change in Kelvin. Now moving to the next topic, that is about the unit of energy. I know the unit of energy is generally what? Joule. But in this branch, means in calorimeter, a science branch of physics, so which deals about this measurement of heat energy, this measures the heat energy in calories. The SI unit is joule, but in this branch, the heat energy is measured in calorie. If you remember, in chapter 2 work per energy, I have explained about the 1 calorie, if you remember. So the next topic is to define 1 calorie. Again, suppose on this pan you are heating a liquid, means water, not liquid, water. In this pan you are heating water. You are giving some energy from that flame, from that burner, and the temperature, whatever the temperature is currently, suppose the current temperature is 14.5 degrees Celsius, and you are providing some heat energy. After providing this heat energy, the temperature rises to 15.5 degrees Celsius. So what is the rise in temperature? 1 degree Celsius. So if there is a rise in 1 degree Celsius, so whatever the amount of heat energy that you have provided to that water is called 1 calorie. Means the heat energy provided to water to rise the temperature by 1 degree Celsius is called 1 calorie. But further I am adding some more words. This is not perfect. Now the water must be 1 gram. If the water is 1 gram, the temperature rises by 1 degree Celsius. Whatever the heat amount is given is exactly now 1 calorie. So how to define? The definition is very clear. The amount of heat given to the 1 gram of water to rise its temperature by 1 degree Celsius. Rising 14.5 to 15.5, how much rise? 1 degree Celsius. And that can be calculated in Kelvin also. 14.5 degrees Celsius to 15.5 degrees Celsius, change in 1 degree Celsius. And I have said the change in degree Celsius is same as change in Kelvin scale. So you can also say the amount of heat energy provided to 1 gram of water to rise its temperature by 1 Kelvin or 1 degree Celsius is known as 1 calorie. Now next, 1 kilocalorie, nothing is changed. That water was amount 1 gram. Change that to 1 kilogram. If that amount is 1 kilogram of water, so the definition will change like this. The amount of heat energy given to 1 kilogram of water to rise its temperature by 1 degree Celsius or 1 Kelvin is known as 1 kilocalorie. The amount changes from 1 gram to 1 kilogram. Definition change. Remember this definition because this definition will be related to the many definitions in the book. Many definitions are there, but basic definition are this. Using this definition, you can learn all the definitions. So what is the definition in the basic? The amount of energy required to raise the temperature of 1 gram of water by 1 degree or 1 Kelvin, 1 degree Celsius or 1 Kelvin is 1 calorie. The amount of heat energy required to rise the temperature of 1 kilogram of water by 1 degree Celsius or 1 Kelvin is 1 kilocalorie. So remember this and keep in mind. Now, the relation between the unit of energy means calorie must have the relation with the SI unit of energy, heat energy. So that is 1 calorie is equal to 4.2 joule or 4.186, but in round off 4.2 joule, and 1 kilocalorie is equal to 4200 joule. Remember this, I have explained this in the chapter 2 also, but according to this, 1 calorie is equal to 4.2 joule, and here 1 kilocalorie is equal to 4200 joule. This must be remembered and must be learned. So our next topic is now heat capacity. Suppose here the two substances are here. One is small, second one is bigger. So on heating both of them, which one will rise its temperature by 1 degree faster? Means which one of them will rise its temperature 1 degree faster? The smaller one, because its amount is less, and the bigger one will take more amount to rise its temperature by 1 degree Celsius. Or you can say, instead of these blocks, take water, 1 gram of water and 1 kilogram of water. If you are heating 1 gram of water, so its temperature will rise faster, or you are heating 1 kilogram of water, so its temperature is rising fast. So what is that? Here 1 gram of water will rise its temperature faster than the there, because it depends upon the amount of substance. So but different amount have different capacities. Instead of block and water, I am giving two substances. Now this is block of iron and that block is of aluminium. Now what you will say? So you will say the aluminium will heat faster because it conducts heat faster than the iron. And if I am changing iron, aluminium and silver, so you will say silver will conduct heat faster. So silver will rise its temperature faster than the other two. So what does it mean? This is all about the heat capacity. So we have seen the substance which passes heat energy faster has less heat capacity, and the one which takes a little bit more time to pass the temperature or to rise its temperature, so that is having more capacity. Again, understand, suppose you are eating something, when you will say I'm done. If you have large capacity, so you will eat and you will take little more time. But if you are having little capacity, you will eat little bit and after little time you will say I'm done. Same way, a heat capacity also. If a substance after heating rises temperature faster, so it means its heat capacity is low. And if it takes a long time, so it means its heat capacity is a little bit more than the other one. So what is the definition? Definition is very simple, like the 1 calorie definition. There was in 1 calorie, remember what was 1 calorie? It was the amount of heat energy required to raise temperature by 1 degree Celsius of 1 gram of water. So change that 1 gram by given mass. Just only replace 1 gram and place their given mass, because we are not talking about the mass. So the amount of heat energy required to raise the temperature of a given mass of a substance. There was 1 gram of substance, here will be given mass of substance. So the amount of heat energy required for a given mass of a substance to rise its temperature by 1 degree Celsius or 1 Kelvin. So that is called heat capacity. So let's see what is the mathematical expression. So here listen, what I said, the amount of heat energy required to raise its temperature by 1 degree Celsius, or you can say the rate of rising its temperature with heat. So the heat capacity, remember this, has symbol C dash, capital C dash. Remember this, don't intermix the symbols in this chapter. It's very important to write the correct symbol. So capital C dash is the symbol for heat capacity. So C dash is equal to the heat energy given divided by the rising temperature. The heat energy given divided by rising temperature. C dash is equal to heat energy upon rising temperature. And giving the symbol, C dash is equal to, the heat energy has symbol capital H. Remember this, heat energy has symbol capital H. So C dash is equal to H divided by rising temperature. So that's not rising temperature, that will be fall also, because we are talking about the change, we are talking about the rate. So C dash is equal to H upon theta. Here theta will be symbol for change in temperature, not only temperature, change in temperature. If I will talk about the initial temperature, final temperature, so I will use T1 and T2. But here I am clearly saying the C dash is equal to H upon theta. C dash is the symbol for heat capacity, H the symbol for heat energy, and theta is the symbol for difference of temperature, or you can say temperature difference, not the only temperature. It's temperature difference. It may be rise of temperature, it may be fall of temperature, but it's a difference in temperature. So this is the C dash is equal to H upon theta is our mathematical expression. But now, what will be the unit of this? Because we know the unit of heat energy, that is joule, SI unit. And here in calorimetry we will measure the heat energy in calorie and joule both, whatever you call. Suppose in question it is given write in SI unit, so we will write in joule, otherwise you can use calorie also. So what will be the unit of this heat capacity? Again, starting from beginning, C dash is equal to H upon theta. So the unit of C dash will be ratio of H upon theta. So what is the unit of H? Unit of H is joule, SI unit. I am talking about the SI unit, joule, and the temperature difference, degree Celsius. So that is joule upon degree Celsius. And also what? The Kelvin, 1 degree Celsius is also equal to 1 Kelvin change. I am talking about the change. 1 degree Celsius change is equal to 1 Kelvin. So you can also write joule per degree Celsius or joule per Kelvin. If I am asking write in SI, so joule is SI but degree Celsius not the SI unit. So the correct SI unit will be joule per Kelvin. And CGS if you are writing, so you can also use joule per degree Celsius, that acceptable as a CGS unit. And if you are writing in calories, so H has unit of calorie and theta is still 1 degree Celsius or 1 Kelvin. So it has unit what? Joule per degree Celsius or joule per Kelvin, calorie per degree Celsius or calorie per Kelvin. So these are the units. Now our next topic is specific heat capacity. Just we have studied about the heat capacity. Now what? The specific heat capacity. There is a little difference in the heat capacity and specific heat capacity. In heat capacity only, we were not talking about the mass of a substance. We were saying what? Given mass of a substance. But if we will talk about the amount of mass also along with the heat and temperature rise, then that will be changed. That will change to specific heat capacity. Means we are specifying the mass. So heat capacity now will be called as specific heat capacity. I'm clearly again. In heat capacity, the mass was not specified. We were talking only given mass. Here we will specify the mass also. That is why the heat capacity is changing to specific heat capacity. So again, I said the basic definition will be same as this definition. Thus, just only 1 gram was changed in that to given mass. Here that 1 gram will change to a unit mass. What is changed? In calorie it was 1 gram. In heat capacity it was given mass. In specific heat capacity it will be unit mass only. So now our definition says the amount of heat energy required to raise the temperature of unit mass of a body by 1 degree Celsius. What I have changed? Unit mass. Again I am speaking the amount of heat energy required by any substance to rise its temperature by 1 degree Celsius of unit mass of a body. Again, the amount of heat energy required to raise the temperature of a unit mass of a body by 1 degree Celsius is called the specific heat capacity. All the definitions what I have said, just they all belonging to the specific heat capacity because we are specifying the mass. Now listen again. The specific heat capacity. What is different here? Only we have added unit mass. So we can say, listen, the symbol of specific heat capacity is small c. For the heat capacity C dash, that is capital C. But for the specific heat capacity, symbol is small c. You can also use small s. But in the book, in your book, it is symbolized with small c. So small c is equal to capital C dash upon m. Why upon m? Because now we are specifying the mass. Unit mass I said na. So unit mass means divided with the mass. So equal to again C dash. What was C dash? That was h upon theta. So h upon theta divided by mass again. And theta in the denominator. So it will come with mass. So small c is equal to what? H upon m into theta. Now cross multiply. What you will get? H is equal to mc theta. And that theta may be rise or fall of a body. What is that theta? The change in temperature. Clear? On giving heat, the temperature will rise, or on taking heat, the temperature will fall. Means depending upon the energy liberated or absorbed, the theta will change to theta rise or fall. So finally what we get, H is equal to mc theta. This is very important equation here in this chapter. So using that H is equal to mc theta, we can solve practice problem 1 and further I think. Unit of the specific heat capacity. Let's see again. The C, small c is equal to H upon m into theta. The C, small c means the specific heat capacity is equal to H upon m into theta. So unit will be same according to the symbol. So H has the unit joule, M has the unit of gram, and C has the unit of degree Celsius. So on writing them all, what is the specific heat capacity unit? Joule per gram per degree Celsius. Remember this, how to speak, how to pronunciate? Joule per gram per degree Celsius. So specific heat capacity is equal to, unit of the specific capacity is joule per gram per degree Celsius. If I am talking about in SI unit, so that will change to SI system, joule per kilogram per Kelvin now. But what I said, the change in degree Celsius is exactly to the change in Kelvin. So you can also say joule per kilogram per degree Celsius or joule per kilogram per Kelvin. But when it will be written specifically write SI unit, so you will write what? Joule per kilogram per Kelvin. Symbol will be this. You are speaking whatever, but per means slash, single slash, not again and again. So joule per kilogram per Kelvin. This is the CGS, SI unit. What will be CGS? Joule per gram per degree Celsius, CGS unit. And if the joule is replaced with the Kelvin, so another unit you can prepare. So now let's move to the numerical section. Let's move to the numerical section. So here the numerical section, chapter 4, unit 1, practice problem 3 and question 1. In practice problem 3, the question is 272 calorie of heat energy is required to heat 0.02 kg of metal of a specific heat capacity 170 calorie per kilogram per degree Celsius to a temperature capital T. If the initial temperature of metal is 20 degrees Celsius, calculate the final temperature. Let's write the initials first. So here it is the given. The heat energy is equal to 272 calorie. Mass 0.02 kg. Specific heat capacity 170 calorie per kilogram per degree Celsius. And according to question, the initial temperature T1 is 20 degrees Celsius. We have to calculate the final temperature because it is given. Calculate the final temperature. So T2 is equal to question mark. What we have the equation, let's write first. So we have the equation H is equal to mc theta. This is the change in temperature, splitting that. So here the heat energy is given 272 calorie. This is very important that if heat energy is in calorie, so specific heat capacity must be in calorie, means both must have the same units. So here both are of them are in calorie. So H 272, mass 0.02 kg, 170 the specific heat capacity value and temperature difference. Let's solve further. Then that is equal to this. Then T2 minus 20 is equal to 80 or T2 is equal to 100. But about the unit, T1 was in degree Celsius, so T2 will also be in degree Celsius. And now I'm ending this session and I'm waiting for your queries, your doubts. Then in the next lecture I will solve them. So till then, take care, be safe and thank you.